So for any student taking pre-calculus in the United States especially, one of the first things you learn in when you start working on unit circles is how to label and find the sine, cosine, tangent, cosecant, secant, and cotangent of the main angles in the unit circle. I'm just going to label this right here. So we have 0, here is going to be 90, here is going to be 180, and here is going to be 270 degrees. But you have to know all the main, I'll call them the main terminal angles, not terminal angles, but reference angles. So here we're going to have 30 degrees, 45 degrees, 60 degrees. Here would be 120 degrees, 135 degrees, 150 degrees. Here we should have 210 degrees, 225 degrees, 240 degrees. This is 300 degrees, 315 degrees, 330 degrees. So most students are expected to know basically the sine, cosine, and tangent of all of these angles. But I have a different take on this, and I'm going to show you why I believe the most important thing to know is one, well, the most important things to know are one, the angles, the value of those angles in the first quadrant, and understand what I call cast. So cast simply means in this fourth quadrant, all angles related to cosine. So cosine, I'll write it here, cosine and secant are positive. Here we have A, which means all angles here are positive, while all ratios here are positive. And over here we have S, so all ratios related to sine are going to be positive, so that will be sine and cosecant. And in this quadrant, all angles related to all ratios related to tangent are going to be positive, so that is going to be tan and cotangent. Now I'm going to use this to show you how to go about this unit circle uh, situation that I see a lot of students just have a lot of stress dealing with. So what I'm going to do now is draw a circle here on the side. We're going to use this circle as our guide, but let's make up a table first. But actually, let's draw a circle here so that we can use this as our guide. So this is 0, 90, 180, 270, and then we're back here, we are 360 degrees. So we also know that the coordinates on the axis, so your intercepts here are going to be seen as cosine sine. So at 0, you have 1, 0. So let's go ahead and just draw some angles. So we're going to say theta here. We're going to say sine here. We're going to have cosine here. And for the sake of this, we're just going to end with tangent. And I'll tell you why ending with tangent is just adequate. So we're going to start with 0. Start with 0. Then we go to 30. Then we'll go over to 45. Then we'll do 60, and then we'll end at 90. 60 here, and then we end at 90 degrees right here. Okay, so at 0, cosine is 1, sine is 0. And something we need to remember with tan is that tan is a derived ratio, which is sine of an angle divided by cosine of the same angle. So the tan here is going to be 0. What about 30? 30 is the sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2. And then the tangent of 30, let's do some rough work, is going to be sine over cosine, 1 over 2 divided by root 3 over 2, which is going to be 1 over 2 multiplied by 2 over root 3, which is 1 over root 3. And then you rationalize this radical, multiply by root 3 over root 3, which is going to be root 3 over 3. So this is going to be square root of 3 over 3. Now for 45, it's going to be square root of 2 over 2. Cosine square root of 2 over 2. You divide this, it's going to be 1. Now for sine 60 is square root of 3 over 2. For cosine 60 is 1/2. You divide sine divided by cosine, you're going to end up with square root of 3. And for 90 degrees, let's just look at our diagram here. For 90 degrees, we have cosine sine. So this is going to be 0, 1. So the sine is 1, the cosine is 0. Okay, so for tan, sine divided by cosine is undefined. And when we get to a topic on drawing, you will understand why this is important. This is going to be what we call an asymptote. Now, what if I told you that this is all you really need to know? Would you believe it? Now, I'm going to show you exactly why this is all you really need to know. So the next thing we're going to talk about here is, let's go to the second quadrant. Let's go to quadrant 2. All right, so in quadrant 2, this is our quadrant here. So this is going to be 120 degrees, 135 degrees, and then 150 degrees. And of course, we here at 180 degrees. Okay, so with quadrant 2, here's something that you need to work with. Let's do our table here. This is sine. This is cosine. And this is tangent. One of the reasons why I'm not a big fan of memorizing things you don't have to memorize is under the pressure of an exam, you are going to fumble. So I always believe it's important to understand the concept of how these are derived, because that would go a long way in helping you deal with questions or understand how to answer questions when you're under pressure. So here we have 120 degrees, we have 135 degrees, 150 degrees, and then we have 180 degrees. Okay, so let's go ahead and do that. What I'm going to do here is I'm going to get the reference angle for each of these. So look at this, 120 degrees. This is our reference angle. So this actually is 60 degrees. So I'm going to write it on the top here, 60 degrees. 135 degrees is reference angle is 45 degrees. So this is 45 degrees. And then 150 degrees, the reference angle is actually 30 degrees. So now we are going to go ahead and come up with the same values. But also remember that in this quadrant, only sine is positive. Everything else is negative. So you might as well just go ahead and put a negative right here. Everything is going to be negative here. So sine 60 is square root of 3 over 2. Cosine 60 is 1/2. Tan is root 3. 45, root 2 over 2. Root 2 over 2 and 1. 30 degrees is 1/2. Root 3 over 2. Root 3 over 3. 180. So 180, important here is going to be -1, 0. So this is going to be 0, -1, and then, of course, this is going to be, there's no sign here, so this is going to be 0. Now, let's go to third quadrant. Let's go to Q3. Let's go to Q3. So we're going to draw again our Q3. So here, Let's create more space here. So Q3, remember that only tan is going to be positive here. So we have 210. Let's go ahead. Theta is going to be sine, cosine, tangent. So here we're going to have 210 degrees, 225 degrees, 240 degrees, and then 270 degrees. So when we get here, our reference angle here, this is going to be the same as 30 degrees, 45 degrees, 60 degrees, and then this is an intercept. So this is going to be right here is going to be -1, 0. So cosine is -1, sine is cosine is 0 because our axis here are going to be 0, -1. So cosine is 0, sine is -1. This is undefined. So let's go ahead and draw some lines here. Then we'll be able to arrive at our values quickly. Remember also that in this quadrant, only tan is positive, so everything else is going to be negative. So sine 30 is 1/2. Cosine 30 is √3/2. This is going to be √3/3. Here 45 is √2/2, √2/2, 1. Here you have √3/2, and then 1/2, and then √3. Now we're going to go to the last quadrant. This is Q4. Q4, so let's draw angles in Q4, which is going to be, this is 270, so we have 300, 315, and then 330. Okay, and then here we have 360. Okay, so let's go ahead and draw our angles. So we have theta, sine, cosine, tangent. So we have 300, 315, 330, and 360. So now we're going to go ahead and figure out the values of sine, cosine, tangent. But before we do that, let's talk about some reference angles. 300, the reference angle right here is going to be 60 degrees. 315, 45 degrees. 330, 30 degrees. And of course, 360 is going to be just like 0 degrees right here. So sine is going to be 0. Cosine is going to be 1. Remember that only cosine is going to be positive in this quadrant. So this is going to be 0 here. But everything else, so cosine is positive, sine and tangent are negative. Sine 60 is √3/2, half, this is √3. 45, √2/2, √2/2, 1. 30, 1/2. And then we have √3/2, and then √3/3. So this is really how you go about getting the value of each of these, the value of these ratios in your 4 quadrants. Now, can you see why it's so important to understand how to get it for the first quadrant, and all the other 3 quadrants will be the application of what you have learned or what you have understood from the first quadrant. The same thing is going to follow through for your radians. What I would say to you is, if you want to work with radians, all you have to do in each of these instances is divide by 180 and multiply by pi.